Hello, welcome to Mechan 2040 Solid Mechanics. I am Globus. The topic for today is the direct stress due to bending. This is the fourth tutorial, so it will cover the content in week 4 and week 5. First, we will do some review of basic structural analysis, which is taught in Mechan 2020 Statics and Dynamics. Besides, we talk about sign convention of beams under the pure bending, as well as the technique of how to draw the shear and bending moment diagrams. Besides, we will introduce the most important topic of this chapter, which is the flexure formula under the pure bending. In tutorial 0, we talk about the first moment of inertia. In this tutorial, we will talk how to find the centroid of a cross-section by using the first moment of inertia concept. Apart from that, we will also introduce the design considerations. Let's first do some basic review of structural analysis. In the structural analysis, there are a lot of supports. As you may see in your previous course or in this course, there are some supports that you should bear in mind with. There are 3 kinds of supports which are very important. One is the roller support. The roller support provides only force in vertical direction. An example in the daily life is the curtain rail rollers with the hooks attached. On the rail of your curtain, there is a roller support like this. And if you hang your curtain on it, the roller support is under an external load P pointing downward caused by the curtain. Consequently, this roller support will drag the curtain upward. In the beam analysis, the typical roller support is like this. For a simple beam, there is a pin as well as a roller support, and as you can observe, the roller support has some wheels under it. That means, therefore, it will just provide a vertical force. Next is the pin. Most of you might be familiar with what is a pin in the structural analysis, but you may not really understand what is the difference between a pin and a fixed end. Typically, a pin provides only force in any direction. Why I say only? Because in the structural analysis, not only force, but also moment will be taken into the consideration. Pin provides only force in any direction. That means for this force, it can be decomposed into the orthogonal components. A typical pin in the daily life is like this. A pin is fixed at the floor, and it is the nut. There is a bar like this, and for this bar you are free to rotate about this pin. For a fixed support, different from a pin, a pin only provides an arbitrary force which can be decomposed into orthogonal components. But apart from the arbitrary force, the fixed end also provides a moment which prevents from this bar from rotation. So still remember that for a pin, the bar will be able to rotate freely about it. But for the fixed end, the bar is completely fixed and no rotation is allowed to be performed, as well as the translation, of course. Another very common support is the simple support. Suppose you have a pin and you place this bar onto a table. Then for this table, it will provide 2 forces. One is the vertical component, of course. Another one is the horizontal component. For the horizontal component, it has often come from friction. If the table is completely smooth, then there will be no such horizontal component occur in this problem.